Okay, for this one, we're going to take a look at side, side, side. So the side, side, side triangle theorem is actually really easy because it's like having a square. So when we talked about in class that if we know that a square has a 3 centimeter side, we know all sides are 3, and there's only one way we can make a square that has 3 sides, and it's just a square that has 3 sides. Now, I could make it look like a rhombus if I tilt it on its side, right? But it's still going to be a 3 centimeter square. This is the same thing with the side, side, side. If someone gives you 3 sides to the triangle, there's only one unique way that you can make that triangle. So I'm going to prove it. All right, so I'm going to start. It doesn't matter which of these sides you start with. I'm going to start with the 5 centimeter. I'm going to do a couple just to prove to you that they're all the same. Okay, so I'm just going to make a 5 centimeter line. Okay, and I'm going to label that A, B. So there's my one side. Okay, so A, B. I'm starting with that one. Now, I have to make a 3 or a 4. Again, it doesn't matter which one you go to next. I'm going to go with the 3 next, and this one's going to be BC. Okay, I'm going to go from BC, and I'm going to make that one 3 centimeters. Okay, now I know my last one is going to have to be 4. So this is where it gets a little tricky, right? Because I'm going to have to make a 3 centimeter line, but then I'm going to have to make a 4 centimeter line on top of that. So I might have to do a little bit of erasing and finagling with this. I'm estimating that 3 is going to be like this, right? So I might just kind of come over here and just make a 3 centimeter line. The problem is when I go over here, that's too long. So I know that it's going to have to go somewhere in this general direction. So sometimes you might need to do a little playing around to get that angle correct, but there we have a 3 centimeter line. So my first 3 centimeter line I drew was like too wide. So I can erase that one. That's why using a pencil is always good. Now this one I think would probably be easier to do digitally. Okay, because, and let me label this is 5 centimeters, this is 3 centimeters, because when you do this digitally, you can change the angle direction. All right, and this one should be 4. Look at that, it sure is. Okay, now, notice I started, what is this, AC. Okay, notice I started with 5, and then I went to 3, and then I went to 4. Now, I can start with another one and label these letters differently, but it's still going to end up being congruent. And I can prove that by making a new one and just starting, let's say, with the 4 centimeter. Okay, so this time I'm going to just go with 4. I'm just going to do this 4. This time I'm going to call this one A and this one B. That's 4 centimeters. Okay, and then I'm going to say, all right, let's go with 5 next. Now, I know I'm going to need a 3 off of this and a 5 off of this, so I might need to kind of play around with my numbers just to kind of see what it's going to look like. But 3 is going to come off like to about here, and then I can make a 5. So you can see how I have to maybe take this angle it up just a little bit, maybe kind of come up here, up to the top. I need to make sure that my line is 5 and the other one is 3, so maybe here. All right, let's try to see if that works. Oh, pretty close. Look at that. See? So this one is 5, and this one is 3. Okay, so I've just constructed it. Just got to make sure, and that was my first estimation, so I'm going to erase that dot. So sometimes you estimate just to kind of get a feel for where the 5 and the 3 needs to go. All right, so there's the 5. So there's B, and this now is C. And then I'm going to connect. Okay, now I'm going to prove to you that these two are congruent. Got my patty paper here, and I'm just going to trace. I'm not even going to use the letters. I'm just going to trace. Again, I'm trying to be as perfect as possible, but patty paper moves around a little bit. So, okay, so then I'm just going to label. This is the 4, this is the 5, and this is the 3. All right, so watch. I'm going to come over here, and I'm just going to kind of rotate things around. All right, there it is. Look, whoop, 4, 3, and 5. Pretty cool, right? And then I can slide it over here and just match it up. Look for the 4. All this is a rotation. So I've taken this shape and just kind of rotated it. Now I could draw a reflection, right? But if I reflect this shape and draw it somewhere else, it's still going to be 4, 3, and 5. So that's the cool thing about the side, side, side. If someone gives you three measurements, three side measurements, there's only one way that you can actually make that triangle. Now we can take this a step further and prove that they're congruent by measuring the angles. Now, I happen to know that this is a right triangle. I happen to know this because I used a Pythagorean theorem. A squared plus b squared equals c squared. The hypotenuse is my c squared, so that would be my 5 centimeters. This would be my 3. This goes back to Math 8. So I purposely picked 3, 4, and 5 because I knew it made a triangle and I knew it was a right triangle. And I can prove that because 3 squared plus 4 squared is equal to 25, which is 5 squared. Okay, this is just a little side math. 9 plus 16 is equal to 25. Okay, so I know that all three of those would work. It's a right triangle. And I can prove by using my measurement tool. And you can see, again, I might be off a little because I hand drew this, but there's the 90 degrees straight up, okay? There's my 90, so I know that this is a 90-degree angle. And I can measure one more. If I just measure one more angle, I might need to make that a little bit longer. If I measure just one more angle, then I don't need the third because I can just use that 180 trick. Okay, so it looks like this guy is going to be kind of in the middle of a number. So it looks like it's about 53. Okay, so it looks like it's about 53. Let's see what this one is. This little one here. I'm going to extend. Sometimes you have to extend your lines when you're measuring. This little one right here. Let's see. Put it on the dot. That one looks closer to a number I could use. This one is like 40, 35. See that 35? It's in between 30 and 40. Now notice I'm not using these bigger numbers because I know this is acute. So it's definitely going to be 35. Okay, so I'm going to go with that one. So this angle right here, I can just do 90 plus 35, and that gives me 125. And then I just need 180, so I could count up 125 up to 180. What would that be? 55, right? So this angle is 55 degrees. Now again, I did construct this by hand, and it may be off just a little, but let's see how close. A little bit, a couple degrees. Okay, so see how I said it was like 53, 54. So pretty close, but mathematically 90, 35, and 55 does add up to 180, which is my goal. Okay, now to prove this even further, we can measure all three of these angles and show that the angles are also the same. So here's my 90-degree angle, and then I can measure my other two. Okay, so that's just a quick, kind of quick video about how to construct a triangle using that side, 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 and a review of the Pythagorean theorem.